Our session, which is called Space Technology in Service of Our Oceans. This is a session where I expect to learn a great deal, and I hope you also. It's going to be interesting to look at the new developments. I'm not going to go into any kind of introduction because we're just going to jump right into things with Jean Dauphin, Director of Earth Observation and Science Programs at Astrium Satellites here in France. Patrick Mottet, who is Senior Vice President and General Manager of Optical Observation and Science Business Unit of Thales. Jean-François Münster, who is Vice President of Scientific Development at Total. Cosimo La Rocca, who is Managing Director of European Satellite Navigation Industries in Germany and Italy. And Richard, known as Rick Spinrad, who is Assistant Administrator at the National Oceanic and Atmospheric Administration in the United States. So you have in front of you an extraordinary bunch of highly technically knowledgeable people to tell us a little bit about what is happening in space observation, of course, for our oceans, but naturally a lot of the space navigation has wide applications. Rick, we're going to start with you. And you're Assistant Administrator of the National Oceanic and Atmospheric Administration, which is a very big mouthful, known as NOAA. So if we say NOAA, we're referring to this. Tell me something just very briefly. This is a government-supported or private?
This is a government agency within the Department of Commerce.
In the Department of Commerce, just so we're clear. And by the way, for everybody here, the Department of Commerce in the United States is not like in Europe. The word commerce does not mean trade, the external trade, the way it does for most. That's the USTR's office. Now, one of the things that we should settle maybe at the start is just to look, Rick, at some of the important contributions that observations of the Earth from space have made to our understanding at all about the planet.
Perhaps the best way to start a question like that is to look at what is fundamentally different about observing the Earth from satellites.
Can you hold this up?
There are a few aspects of that fundamental difference. One is that one can quantify physics and chemistry of the Earth in ways of the surface of the Earth primarily, in ways that we could not with other instrumentation. And of course the other main issue is that we can do this synoptically. That is, we can effectively get a photograph of very large areas of the globe in one shot in time. And done carefully, one can actually eliminate some of the sorts of biases of observations that are done over time. So over the last half century, we've taken advantage of these two unique characteristics of remote sensing, that is, observing from satellites, to address a range of issues in climate, in weather, in ocean studies. In climate, for example, this is where we have gotten some of our best information about sea level rise, by being able to look synoptically at how the surface of the ocean is changing over long periods of time. The ozone hole detection and characterization of upper atmospheric ozone has been best done using satellites. On the weather side, the phrase of the day is numerical weather prediction, and in fact, our ability to forecast weather, and in fact, have weather forecasts for 3 days today that are as good as the weather forecast for 1 day was, say, 20 years ago. Because of those kinds of observations from satellites. If you look at the ocean side, any number of new discoveries and applications have come out of remote sensing. Our understanding of the dynamics of the ocean. Years ago, because we were transiting the ocean on ships that went 10 miles per hour, we could not necessarily get that single photograph of what's going on. So features like warm core rings and eddies in the Gulf Stream are now well understood. In addition, we can now look at things like the color of the ocean and determine how much life there is in the ocean and how it's changing over time. This has helped fisheries. It's helped for a better understanding of carbon, global carbon. So you can see that there's a wide range in the climate, weather, and ocean arena benefits that have been reaped as a result.
Now, in the recent years, Rick, there have been a lot of talk of Jason 2, Jason 3, and the post world, the post Jason 2 world. Can you tell us a little bit, first of all, can you explain those terms? And then would you tell us perhaps a little bit what NOAA is actually doing over these last 16 years now, the users, what is needed, is Jason 2 and the post-Jason 2 world enough? What's going on here?
Well, what we're talking about here is the set of satellites known as altimeters that measure the sea surface, the height of the sea surface. And it's been a wonderful cooperation between EUMETSAT, CNES, NOAA, NOAA, NASA in the United States, and actually goes back to a satellite system, Topex Poseidon, which flew for several years to demonstrate the concept of how to actually make these observations.
Topex Poseidon was an American system.
It was a joint effort.
Was it a joint effort?
The Jason 1 and Jason 2 were the evolution then from that concept. Jason